Hello and welcome back to LFI Educates. Today we are going to study about dimensions of a physical quantity. Dimensions of a physical quantity. Let us know first of all what is dimension. Dimension of a physical quantity is defined as the powers to which the base quantities are raised to represent that physical quantity. We call it as dimensions of a physical quantity. I'll write down here. It is the power, or we call it as exponents, to which the base quantities are raised to express that physical quantity. So if you raise the base quantities to express the physical quantity, then we'll call it as dimension of physical quantity. Basically, the base quantities, as you know, there are 7 base quantities: mass, length, time, luminous intensity, electric current. Then you have amount of substance and temperature. So any one of them among the 7, if you raise to the power, then that representation will be called as dimension of a physical quantity. Now let us take some examples, like say force. Force, as you all know, it is mass into acceleration. So mass, we know that we represent with kg. Acceleration is meter per second square. Write down the units, then also you can write the dimension. Mass, m we write. This one we'll put at the end. Mass, here power is nothing, is 1. Meter, it is for length, this is also 1. And time, it is downside, so if you take it up, it will be time will be power minus 2. Now if you write this within this square bracket, then it represents the dimension of a physical quantity, and this is the dimension of physical quantity, that is force. Here on the board you can see this also can be written as m. You can write simply m l t power minus 2 as well. When the power is 1, if you do not mention here also, it is okay, but you must be sure that one square bracket must cover them up in front and at the back. There is other physical quantities, like say, let us take a simple one, area. Area we know is unit is meter square. So in that case, what you will do? M, mass is not there, 0 you can write. L, length is there, 2. And then time, not there, so you can put 0. Or this one you can write it as only simply T square, L square. The other two quantity does not exist. Mass to the power 0, any number raised to the power 0 is 1. So if you don't write also, it is okay. It will be simply L square. Like that, all other physical quantities, you can write down their dimensions. We can raise them to their powers, their base quantities. Now, let us discuss about dimensional formula and dimensional equations. Dimensional formula. Dimensional formula indicates how and which of the base quantities are related to the physical quantity. That gives us the dimensional formula. Actually, while explaining you about dimension of physical quantity, already I have done and I have shown to you. Suppose say you are finding the dimension of speed. Speed, we write this as distance by time. Distance by time. So distance is in meter, time is in second. So if I write this dimension, it will look like this: L and T power minus 1. Mass does not exist. So this way of writing itself, we call it as dimensional formula. So here in this case, the base quantities are related with speed are length and time. So if you represent this way, we call it as dimensional formula. And when we talk about dimensional equation, now the same thing, dimensional equation, when we say, then the equation that exists between the physical quantity and the dimension, we call it as dimensional equation. Suppose I want to write dimensional equation for speed, so I will write as, within dimension I will write down on the left hand side, and then right hand side, as you know, it is L T power minus 1. So it represents a dimensional equation, because both the sides we have put dimensional symbol. At the same time, in the middle you have this equality sign. Now let us discuss about dimensional analysis and its applications. With the help of dimensional analysis, we can first of all check the correctness of a relation. We use it to check the correctness of a relation or a formula, whether it is okay or not, we can check it. The second application you have to convert, we can convert one system of unit into another system. When we say one system of unit to another system, then you know the systems we discussed: FPS system, that is British system. Then we know about CGS system. Then we know about MKS system. Then we know about SI system as well. So from one system to another system also we can convert by the method of dimensional analysis. Then the third one, we can even deduce. Deduce means obtain a relation or derive a relation between physical quantities. To deduce a relation among physical quantities, we can find out a new formula, or we can derive a formula with the help of dimensional analysis. Now let us check one by one how we can check the correctness of a relation. The first one, suppose I am giving you one question here. Check dimensionally the correctness of the relation we all know that kinetic energy and potential energy both are equal. Let me say mgh, kinetic potential energy, this is your potential energy, is equal to kinetic energy half of mv square. Suppose it is given like this, the question to you, then to check the correctness, you do the solution this way. Left hand side is equal to dimensions on left hand side. You can write dimensions on LHS is equal to mass, kg we know, G, acceleration due to gravity, meter per second square, and height is length, so it will be in meter. We can write this as kg, meter into meter is meter square, second square is downside, so you take it up. Then you can write mass, length, and time. You can write on its dimension. Your LHS dimension we have found out. Now you will find out the dimension on RHS. Half, this is a number, so it doesn't have any dimension. It is dimensionless constant. Mass, it is kg. Velocity is meter per second, but it is squared. It is squared. So this one you can write kg meter square second to the power minus 2 if you lift it up. Then you can write on its dimension. Mass is there, length is 2, time to the power minus 2. Then you can look left hand side as well as right hand side. The dimensions are exactly the same. So this relation is correct. You can check it like this. Since dimension on LHS is equal to dimension on RHS, the relation is correct like this. Then the next one, to convert one system of unit to another system, let us see how we can do that. Here I have given you one question on the board. You can see when 1 meter, 1 kg and 1 minute are taken as the fundamental units, the magnitude of force is 36 unit. This is for one system of unit. What will be the value of force in CGS system? So first what we have to do is the physical quantity that we are dealing with force, that we have to identify. What is the physical quantity you are dealing with? Suppose here we are dealing with force. So force dimension you will find out mass into acceleration. Mass is kg, acceleration is meter per second square. Then find out its dimension, m l t power minus 2. It's 1 here. So after knowing this, you will write down, when you do the solution, you will write down the dimension formula. Of force is equal to, you write down m l t power minus 2. This is your first step. Then you have to know one thing. For any physical quantity, the magnitude of that physical quantity and the unit, they are always directly proportional to each other. The product of the magnitude and the unit is directly proportional to each other. So now if the product of their magnitude and magnitude, suppose n1, for the given information we'll take it as n1 suppose, then unit is suppose u1, we write n for the magnitude and this is for the unit. It will be always equal to the magnitude of the second physical new system of unit, and the unit will write it as u2. So from here what we can find is n2 is equal to u1 by u2 times n1. This relation first we'll try to find out. Now let us make a small table and see the given system, this is in SI unit, this is also in SI unit, length, this is mass. This one in minute, we'll change it into SI unit, we'll write it in second. Then the numerical value is given as 36 unit. So you come to know from here. Like this you can do in SI system. And you're going to convert it into CGS system. Here SI system, all we are taking as 1, length also 1, time also 1, mass also 1. N1, the value is given to you, 36 unit. You write 36. Then length is given as 1 meter. You write 1 meter. Time T1 is 1 minute. 1 minute, we write it as 60 seconds. And then mass is 1 kg. So we write 1 kg. Like this you write down. Then in CGS system N2, we are going to find out. We don't know. N2 is not given. Then length L2, it will be 1 centimeter. In CGS system, the centimeter, gram and second. Then you have T2. Time is same, 1 second. Then mass, it is 1 gram. Now after writing this, you will put the values in this formula. N2 is equal to N1 times U1 by U2. U1 is here and U2 is here. MLT you can write MLT, this power is 1. Everything you took it as 1, 1, 1. Mass, length and time, downside you took it as 2, 2, 2. You write down. And the powers also you already know. If you separate them, here the powers are 1, 1 and here minus 2. From where we know this is the dimensional formula of force, 1, 1 minus 2. Here also powers are 1, 1 minus 2. In dimensional way if you write. Now after writing this, N2 is equal to N1 value also you know it is 36. Then you will separate it like this, M1 by M2 raised to the power 1, L1 by L2 raised to the power 1, then T1 by T2 raised to the power minus 2, both minus 2, minus 2. After this, we'll put the values 36, M1 is how much, then 1 kg, 1 kg, M2 is how much, then 1 gram raised to the power 1, L1 is how much, then we'll say 1 meter, divided by L2 is how much, then 1 centimeter, this also raised to the power 1, T1 is how much, then we'll say 60 seconds, and T2 it is 1 second raised to the power minus 2. Then this is 36. 1 kg is 1000 gram divided by 1 gram. Gram cancel it. Power will still remain 1. 1 meter is equal to 100 centimeter. This is 1 centimeter. Here also power is still 1 centimeter cancel it. Then here second you can cancel it. 60 raised to the power minus 2. Now these powers you can use it here, then it will become 36 into 1000. 1000 by 1 is 1000. 100 power 1 is also 100. And here 1 by 60 you will get minus 2 power. So downside if you bring it will become plus power 2. It will become square. Then this is 36 into 1000 into 100 into 1 by 60 into 60. These two zeros you can cancel out. 6 are 36, you can cancel it out. Then what is the remainder you can see? it is 1000, that is 10 to the power 3. So this value n2, it came out to be 10 to the power 3. So this is the magnitude of force in the new system, that is CGS system. And if you use the unit, it will look, CGS unit of force is dyne. So in a new system, if you convert from SI to CGS, then you will get 10 to the power 3 dyne, the given values. Like this you can get into the new system. Now let us see the third application of dimensional analysis. That is the third one, deducing relation among physical quantities. Here is one question. You will get question like this. So what you have to do is, using this question, following up this question, you will have to derive a formula. Now here the question is regarding a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillation of the simple pendulum depends upon. So on what factors the oscillation of the simple pendulum depends? That is important to know. The period of oscillation, that means they are talking about a time period. Here you can see, derive the expression for its time period. We write it as capital T. So what we'll do first is, you take the dimensions, or you take the physical quantities which are related with time period. Time period is directly proportional to length. You write down time period is directly proportional to mass. It is also directly proportional to acceleration due to gravity. Acceleration due to gravity G. By combining these three, you raise to the power here, suppose x, y, z, or a, b, c, you can raise to the powers. Then with these three equations, 1, 2, 3, that it is being given in the question. From there you can find out the time period is directly proportional to L to the power A, M to the power B, G to the power C. These powers you are taking by yourself. You don't know what is their value, you are going to find out. You have to calculate it and find out. So time period dimension, if you write down on both the sides, or first of all you try to remove this proportional sign, take a dimensionless constant k, L to the power A, M to the power B, G to the power C, make it like this. After that you take dimension on both sides. Here mass does not exist, length also does not exist, time you have 1, power 1 you write. Then here k does not have any dimension, so the thing which does not have any dimension don't write. Length L, power 1 is raised to the power A. Mass M we write, this also power is 1 raised to the power B. And acceleration due to gravity, meter per second square, length per time to the power minus 2, you raise to the power C. This expression you can write as equation number. If this is 3, this one you make it as 4. Then from this relation you can find out the values of the constant terms A, B and C. Here M power 0, L power 0, T power 1. If you write like this, here L, so we'll group together L. 1 into A is A, and here power is C, so A plus C. You can write, better write outside like this, you can write L. Then M is individual, only one term you have, power B. And T also you have only one time, T is raised to the power minus 2C. You can write here minus 2C. Now we'll compare the powers of the dimension on both the sides. Comparing the powers, of dimension on both sides. You will try to calculate the values of a, b and c. Here L, it is a plus c power, and here L power is 0. So a plus c is equal to 0. You can write a plus c is equal to 0. Then mass power is b. Here mass power is 0. So b is equal to 0. So b is equal to 0. And here minus 2c is the power of time. Here time power is 1. So minus 2c is equal to 1. Then from here b already you know, b value is 0. From here you try to find out c. c is equal to minus 1 by 2. This minus 2 will come down. Now you know b and c. So after knowing b and c, here b is not present but c value you can put it here. So it will give us a plus c will become minus half equal to 0. So it will give you a is equal to 1 by 2. Like this a, b and c you can find out. Once you find out the values of a, b and c, then you can put this in equation number 4, where you left like this before writing the dimension. Putting the values of a, b and c in equation 4, we will get t is equal to k, then L to the power a, L to the power half, a is half, m to the power b, m to the power mass to the power b is 0, so everything will become 1, and then g to the power c, g to the power c, c is power minus 1 by 2. So this one if you write in a proper way, t is equal to k, m does not exist. This is L to the power half, and this power minus half, if you take it down g, then it will become plus power half. So it will give you t is equal to k, both power half means square root of L by g. Like this you can find out the relation among the physical quantities. That means mass, time period of oscillation does not depend upon mass. There is no value for mass. But this dimensional analysis has some disadvantages. Here you can see the value of k. We cannot find out with the help of dimension because it is dimensionless constant. It does not have any dimension. The exact value of k here is, in a simple pendulum, it is 2 pi. This is the constant term which you cannot measure with the help of dimensional analysis. Another disadvantage of dimensional analysis is that we never know which quantity is vector and which quantity is scalar. With the help of dimensions, we cannot. Only we can check the correctness of the relation among the physical quantities we can find out, whereas the constant terms cannot be done. These are some of the limitations of dimensional analysis. We have come to an end of this chapter, chapter number 2. Thank you and have a nice day. Stay tuned with LFI Educates. We'll come with a new chapter. This is chapter number 3 in the next coming video.